Hi boys, so we're going to be doing a continuation of the lesson that we learned yesterday. So the same rules still apply of you knowing how to break down large radicals, knowing your square roots, things like that. But we're only going to focus on one thing today, and that's going to be with dealing with having a radical in the denominator of a fraction. So there is a certain process that you're going to learn today of how to get rid of the radical in the denominator. So, like I just was saying, the lesson is called about rationalizing the denominator. So it pretty much means to get rid of the radical in the denominator. And it's pretty much as me saying, giving you a fraction and you reducing it to lowest terms. So if you didn't reduce it, it would be wrong. It would be unsimplified. This is the same idea, where I give you a fraction and it cannot contain a radical in the denominator. If it would, it wouldn't be simplified yet. Okay? So this process is called rationalization. So here's an example of what a problem would look like. So this, if you left this as an answer, I would mark it wrong, because you cannot have a square root on the bottom. Oh, it can be on the top, but it can never be on the bottom. So here's the process of what you would do. You would eliminate the radical from the denominator by multiplying this problem by an appropriate value of 1. So we're not changing this problem right here. We're going to multiply it by 1. Now, it's not going to just look like a 1. It's going to be a value of 1, because you can multiply any number in the world by 1 and you would still get that number. Okay? So we're not trying to change the problem, because if we did, then we would be changing the problem. So here's our first example, which is the one I just showed you. So you have 5 divided by the radical of 7. So I'm going to choose this appropriate value of 1. So I'm going to multiply. Oops. Here's what it's going to look like. So this is my appropriate value of 1. It's going to be the square root of 7 over the square root of 7. Now you're probably wondering, well, where did I get the 7 from? Well, look at the denominator of the problem. It is 7. If you're trying to get rid of that number, you need to multiply by that number. And I'm not changing my problem, because the radical of 7 over the radical of 7 is still going to equal a 1. Okay, so this is what you learned yesterday. So let's see if you guys remember how to do this. So multiply outside numbers with outside numbers, inside numbers with inside numbers. So you have a 1 right here. So you have this 5 times this 1 is 5. The radical of 7 stays because it doesn't have another buddy in the previous fraction. This and this, you're going to get the radical of 49. And as you know, you should know the radical of 49, which is just a 7. So this is my simplified fraction. Now the one thing you need to be sure of is look at these outside numbers. You have 5/7. If you can reduce your outside numbers, you would. But in this case, we can't. So like I was just saying, this is still my answer. Okay. So let's look at this one. You have 2 times, don't forget there is a dot right there, 2 times the radical of 18, all divided by the radical of 3. Okay, so there are multiple ways to do this. I'm just going to show you one way to not confuse anybody. So this is our problem down here. We can't have this radical of 3 in the denominator. So I'm going to choose my appropriate value of 1, which is the radical of 3. Again, I'm not just choosing 3 out of thin air. The 3 comes from the denominator of the problem. So there's a 1 here. So you have this 2 times this 1, because you have 2 outside numbers, and I believe you get 2. And then it looks like you need to do 18 times 3, which is your 54. And 3 times 3 will be the radical of 9. I'm going to clean this up a little bit. And I believe I get a 3 on the bottom. Now, again, I'm looking at this 2 and this 3. Can't reduce those. However, still not fully simplified. This needs to be broken down. And this is what we've been doing for quite a while now. So I'm going to take my my 54, and I'm going to break that up into square root of 9 times the square root of 6. So I get 3 radical 6. So this is now going to replace this up here. So this and this are the same. But I have this 2 right here. So this 2 with this is going to become 6 radical 6. Divided by, well, my 3 can't really do anything. Look at my 2 and 3. Can't reduce those. So I'm pretty sure my answer is going to be 2 times the radical of 6, all divided by 3. All right, now this one's interesting because the whole thing is underneath a big radical. So you learned a property when we were back in school, and the property was to do this. You break it apart like this. Okay, now you don't know the radical of 7 and you do not know the radical of 8, so you need to somehow get rid of that denominator of 8. So like we've been doing, we're going to choose this appropriate value of 1, which coincidentally is the radical of 8 over the radical of 8. And the bottom will get the radical of 64. This 7 and this 8 are both inside the radical, so I believe you would get 56. And radical 56 over 8, I believe. And we should make sure that we cannot break down my 56, and I do not think there is a square inside 56. Oh, there is a square inside 56. There is 4. So we're going to break down. So 56 is radical 4, radical 14. So this is 2 radical 14. So now that is becoming my numerator. And I did not have a number up here. It was just a 1. So this is what I get to keep right here. And then I have my 8. Now what we need to be looking for is to see if we can reduce our 2 over 8, which I believe is 1 radical 14 over 4. And this 1 right here is not needed, but if you would like to write it, you can. Next one's pretty easy. So you have the big radical 40/49. So same property as before. We are breaking apart the radical into 2 smaller ones. Now, I'm pretty sure that you should know that the square root of 49 is 7. Wow, so you just get a 7 and you get the radical of 40. So if you look at this problem, you already have a whole number on the bottom, so you do not need to rationalize it. But what you do need to do, as I know you're all thinking this, is you need to break down 40. So 40 is 4 and 10, so you get 2 radical 10, which is now going to be my numerator, and the 7 still stays And I don't think you can reduce 2/7. So there's your answer. So these 4 problems were all about rationalizing the denominator. Now my next 2 are going to look a little bit different than this. So they look like this, where you're going to take 2 radical problems that contain both fractions. So when you see a problem like this, the first thing I need you to do is you need to change into improper fractions first. So if we don't remember how to do this, you do big number times the small one plus the top. Sorry about that. So you're going to get 24/7 times, so we've got 2 times 3 plus 1. What is that? 7/3. Now you're going to put under 1 radical. So 24/7 times 7/3. Reduce, so 7 and 7 become 1. 3 and 24 become 8 and 1. So it looks like you're just getting an 8. However, where did the radical symbol go? Radical symbol. And this is over a 1, so this 1 does not matter. But we need to break this apart. And it looks like my final answer will just be 2 radical 2. All right, last one. So for this one, we do not have mixed numbers, so we don't need to turn them into improper fractions. So this is the first step, is put all fractions underneath one big radical, which is what my second step was for my first problem. Looks like we need to reduce. Oops. And this would become a 1, this would become a 2, that would be a 1, this would be a 9. So you're getting 2/9. However, that is the radical of 2/9, which is the property that we learned before. Radical 2 over radical 9. Now, like this lesson is all about, you cannot have the radical underneath in your fraction. However, we don't need to do the whole process, because you should know that the radical of 9 is just 3. And this 2 cannot be broken down anymore. So here is your final answer. Okay, so the whole point of this lesson was to rationalize the denominator. And what that means is you're getting rid of the radical in the denominator by rationalizing it. And by using an appropriate value of 1. So here's your assignment. It is just part 2 of the assignment from yesterday. So good luck, boys, and happy April Fool's Day.